Now, before we discuss Newton's law of gravitation, which is a very important part of this topic, we need to discuss what a point mass is, or point mass approximation, as I've used the word, क्या होती है. So, remember here we talked about a point जिसके ऊपर gravitation field के lines के arrows आ रहे थे. So, imagine कि ये point Earth है. Now, Earth is not a point, it is a huge planet. लेकिन फिजिक्स और थ्योरीज के टर्म में जब हम इसके बात करेंगे तो हम इसको एक पॉइंट मास कंसिडर करेंगे. व्हाई? फॉर द ईज ऑफ द कैलकुलेशंस. सो लेट्स टॉक अबाउट व्हाट अ पॉइंट मास इज. एक पॉइंट मास एक ऐसी यूनिफॉर्म बॉडी है जिसका मास हम कंसिडर करते हैं टू बी इवनली डिस्ट्रीब्यूटेड. इट डज नॉट मैटर कि वो कितना अमाउंट ऑफ एरिया कवर करती है, कितनी रीजन कवर करती है. इन आवर formulas we consider a point mass or refer to certain objects as point mass just to make our lives easier. हम ये कंसिडर करते हैं कि उसका जितना भी mass है वो evenly distributed है. So a point mass is a body that covers a large distance as compared to its size. So as to study its motion, its size, dimensions can be neglected. So dimensions can be neglected. So that's a very important point when discussing ideas about gravitation. Now let's talk about what Newton propagated through his law of gravitation. Law of gravitation ये कहता है कि gravitational force between two bodies outside a uniform field, ये जो मैं वर्ड यूज कर रहा हूँ, these are very important, you should keep them in mind कि हम इधर एक यूनिफॉर्म फील्ड की बात कर रहे हैं कि gravitational force between two bodies outside a uniform field is defined by Newton's law of gravitation. Now न्यूटन्स लॉ ऑफ ग्रेविटेशन ये कहता है कि ग्रेविटेशनल फोर्स जिसको हम सिंबल जी का देंगे, बिटवीन टू पॉइंट masses. Remember that we just talked about the idea of point masses. This is where it's important. Force between two point masses is directly proportional. This is the symbol that we use for directly proportional. I'm not going to write it down for you as I'm speaking it already. Is the product of the masses and inversely proportional to the square of their separation. To the square of their separation. Now इस आइडिया को जब हम सिंबल्स में रिप्रेजेंट करेंगे तो शायद ज्यादा इजी हो जाएगा. सो हमने कहा कि a force that exists between two masses, point masses, which is a product M1. We use the dot terminology for the multiplication sign because it's just easier to this way. And inversely proportional. Remember inverse relation जिसके अंदर वो इस तरह का होता है, inversely proportional to the square of their separation. This, students, is Newton's law of gravitation represented through symbol. Realize how easy it is to communicate theories and ideas just through symbols. So imagine that you had a large body, let's call it our sun. Then you had a smaller body, for example, the moon. There will be a force that would be equal in magnitude that would exist between these two. Use R for the distance between the two bodies here. And this would be the force of attraction. Fg here and Fg here, using the same symbols because they're just equal in magnitude. Acha, although planets are not point masses, we just you like to use this term. Why? Because जब हम solar system में जाते हैं, तो the distance that exists between these bodies is so large that, as we discussed earlier, we just neglect the dimensions. So we just consider them to be point masses. The two ideas that you need to keep in mind is that it's the product of their masses, and it is directly proportional and inversely proportional to the square of their separation, जो कि बहुत ज़्यादा important है. Now, let's talk about the impact that the gravitation field has on certain bodies, for example, the Earth, the Moon, and even human beings. And let's discuss this through a worked example. So आप सब इसकी implementation देख सकें of the formula that we just had. Question is, a satellite with a mass of 6,500 kgs is orbiting the Earth at a distance of 200 kilometers from the Earth's surface. The gravitational force between them is 37 kilonewtons. So Fg is 37 kilonewtons. Calculate the mass of the Earth. Now, they've given us the radius, which is a radius of Earth, which is 6,400 kilometers. We have to use this formula to calculate the mass of the Earth. And we have the force, we have mass of one of the satellites, we have the radius, which is the separation here, and we have Earth's radius. So let's implement these. Let's put these values in and use it. So first of all, let's rearrange our formula to get the mass of Earth. And this is, by the way, the gravitational constant. It has a certain value, 6.67 into 10 raised to power minus 11. I guess you'll just get this everywhere in your exams, in data booklets, or either the examiner will mention the value in the question. So the separation R would be, so remember that they said that the separation is from the surface of the Earth. The Earth ka surface hai, but we have to go to the center, because this is where the separation is from. This is the surface. So we have to take into consideration the radius of the Earth as well. So the separation is going to be 2,000 kilometers plus the 6,400. It would be 8,400 kilometers, or 80. So this is represented this way, 2 meters. Now let's substitute our values in using this formula right here, 8,400 into the force of gravity and the gravitational constant, and into the product of the mass of the satellite, and we get the mass of the Earth to be equal to this value.